So here's the Ricky Roth formula. This one here represents O. This is O for offense. And we'll walk through what each of these three components are. And this one here is D. D. This part. So O minus, here's the minus sign. O minus D, this whole term here, equals G. And G again is modeling the games behind for each of these league seasons. So let's go through each of these things. Now this might be familiar to folks. Hits plus walks plus hits by pitches divided by at-bats plus walks plus hit by pitch. This is on base percentage, OBP. Now this is a little different. We may or may not have covered this very well. We did in the early sections looking at runs define this one. But total bases divided by at-bats you should recognize as slugging. But when we take out the hits, we get a different number, and this is called isolated power. It's a measure of power. This is what Roth and Ricky called a measurement of clutch. Clutch. Not the clutch that gets debated in sabermetrics circles sometimes. What Roth and Ricky meant by clutch was the events that occur on base paths, like speed, good running speed, counts as clutch. Taking the extra base, that's also clutch. Stealing, stolen bases were clutch, according to Ricky. He also mentions manager savvy, and this just must mean good managing by managers. And then, of course, the old timely hitting. In other words, hitting just when you needed it. So all these ideas of clutch are represented here. It's basically your run scoring divided by your run scoring opportunities, how many times you get on base. So you get on base through your hits, your walks, and getting hit by pitch. We ignore a few others here, so does Ricky. But the runs you score divided by the times you get on base is what Ricky calls clutch. So the sum of OBP, isolated power, and this clutch term add up to give you O, the offensive number. The offensive number. On the defensive side, we have 4 terms instead of 3. The first one here is just the opponent's batting average. The opponent's batting average. Remember what batting average is? Hits divided by at-bats. So this is the opponent's batting average. This is a strange term here. This is the percentage of hits and walks that the opposing team gets. The percentage of hits and walks that the opposing team gets. And so you count at-bats, walks, and hit by pitches, and you just count the walks and hits by pitches. This is a strange mix of things here. You could have just done opponent's on-base percentage, and you'd have the melding of these two. But for some reason, they wanted to keep batting average separate. So they have a batting average term and a walk and hit by pitch getting on base term. This one here. This third one here is called pitching clutch. And similar to the hitting clutch up here, this one here, this is earned runs. The earned runs allowed by the defense divided by hits plus walks plus hits by pitches. Sort of the alternative to runs scored by the offense, earned runs by the defense. And this gets at the same thing. How does the defense do at managing speed and keeping the other team from taking bases or keeping the other team from stolen bases. So that's what Roth and Ricky talk about when they talk about pitching clutch. And then there's strikeouts. Now you got to remember what's going on here. This is a negative term and then another negative term. So strikeouts were supposed to be good. That was the idea, that strikeouts would be good here. And there's a missing parentheses here. Strikeouts would be good, so you'd subtract them in this term, and this is strikeout percentage. Strikeouts divided by plate appearances, essentially. Finally, this term here, F, has to do with fielding. And for completeness sake, Roth and Ricky put fielding in here. Sort of good fielding would be the bonus here because it's another minus sign. But they don't even address this in their formula or in the article here. So when people look at this formula now, they just put a 0 here because they don't know what to do with it. But theoretically, the good fielding would go here for a team if you could measure it well. And Ricky makes comments like there's nothing they can do with fielding. They can't measure it well. So the article doesn't go into what this F is at all, so people just make it 0. Now, two terms have a ratio associated with them. Strikeouts, as you know, the theory was that they would be helpful to your defense if you had strikeouts. And this is sort of a truism today. Strikeouts are good for defense. But they didn't turn out to be as important in their regression analysis, their correlation analysis, as pitching clutch, as these two terms here on opposition on base percentage. So what they did was, based on the relationships they found in the correlation analysis, they decided to divide the strikeout percentage by 8 to make it fit better in their model. So this is sort of remodeling strikeouts, even though it did help defense, not as much as they thought the other terms did based on their regression analysis. Same thing is true here. When they did the analysis, they found that OBP was highly correlated with offense, clutch was highly correlated with offense, and power less so. Power wasn't as correlated with offense. So they take 75% of power. 75% of power in their formula. Here they're only taking 12%, 12.5% of strikeout percentages into the defensive formula. Now there's a lot of comments here, but basically you got to remember this term here, this top one is O. O for offense. And we subtract off defense, this term here, to model this efficiency of a team. The efficiency of the team. So we go back. I'm going to go back one slide to the standing slide that Roth and Ricky start with. O, offense. This is straight up runs per game. This is not the formula that is on the next slide. D for defense. This is runs allowed per game, remember. This is just straight O minus D. But the whole point is to model the efficiency here, how well teams do relative to one another. So this is the formula. It has its basis on things we're familiar with. On base percentage, isolated power, opposition on base percentage, some measure of the ability to strand runners, or some measure of the ability of getting runners in when they're on base. Strikeout rate, defense. All this is put in, and people have studied these formulas to see how well they do today, how well they do with data following 1954, and how well they do with data even going further back than Roth and Ricky looked at. And it holds up pretty well. This formula isn't bad. And remember, this is an old formula. This is 60 years ago. So sabermetrics had a 60-year-old analytics point here. Now, Alan Schwartz in The Numbers Game, his book, makes the claim that nobody paid attention to this, though, even though it was published in Life magazine, one of the most popular magazines of the day. It was widely disseminated, and Branch Rickey was one of the more well-known baseball front office personnel. Even though all that's true, this really never took. There was no traction to this. Teams really didn't embrace this at all to going forward. So this early baseball science, this early sabermetrics, like a lot of other early efforts, kind of just faded away and wasn't embraced by the clubs themselves, by the managers and the players themselves. Unlike today, when we obviously see much more sabermetrics inside the game itself. And finally, I want to leave you with some more quotes from the article. You can read these on your own. It's really interesting to think that these were from 60 years ago. And one of my favorites is fielding averages, utterly worthless as a yardstick.